Hello, and welcome to this first presentation on limits. I guess this is the very first presentation I'm going to do in my calculus playlist. So I guess I wanted to talk, I should start out really talking about, I guess, what a limit is and and when we start talking about a limit, we're going to start talking a little bit about how calculus is really going to be a little bit of a departure from what we've typically done in algebra, what you might have typically, I haven't made my algebra videos yet, but what what you might typically see in an algebra class. And the idea of a limit is a pretty straightforward idea, but it can be a little confusing when you start getting your head around it first off. And I think one of the best equations or one of the best functions to really start tackling the idea of a limit with is to start talking about the function. So I'm going to say f of x is equal to x over x. So if we were in an algebra class and I said, okay, we're going to just plot this function f of x is equal to x over x, or that's the same thing, we know is this is the same thing as y is just equal to x over x. And probably you can imagine, every x, so for any x I give you, you can give me a y back, is pretty much what this function is saying. So let's say, and this is our graph over here, that that's 1 on the x-axis. So I'm going to put 1 into this, and we have 1 over 1, so therefore y would be 1 right there. And then I've got 2 on my x-axis. I would have put in 2 on the top and 2 on the bottom, and y again would be 1. And you can probably see, if we could do the same for 3, have 3 over 3, put that in here, and y again would be 1. And probably you can see that the solutions for this equation, it's just going to be a line, right? It's just going to be a line at y is equal to 1. That's what that it's not completely what it's going to equal, but at least that's what our solutions are going to look like. And it's somewhat obvious, right? Because we could just say, okay, we're going to simplify this, and we've got an x in the numerator of our fraction and an x in the denominator. So we could just cancel those out and say that that's equal to 1. Except there's one problem, and this problem is really going to be sort of the key to understanding limits and the key to understanding most of what you'll see in a first-year calculus course, or at least the first half of the first-year calculus course, is that this function we were given f of x is equal to x over x. We can simplify that, and we can simplify that and cancel that out to 1, but there's just one problem. What happens when we set x is equal to 0? Well, when we set x is equal to 0, we've got 0 in the numerator divided by, actually I'm going to write that down here. We've got 0 in the numerator divided by 0 in the denominator. And this, right here, that's a problem. We know that dividing anything by 0 makes the function undefined. So while we know what this function is going to look like, it's going to look like a line at x is equal to 1, because the function we were given was this one. We were given the function x divided by x. We weren't given the function in its simplified form, as just saying f of x is equal to 1 or y is equal to 1. So therefore, we know that we can't put 0 into this expression. We know that when we put 0 into this expression, our function is undefined at that point. So, and maybe you've seen this before. What we have to do at that point is we can't say that our function's defined. If we were going to graph it, this solid line here, that just means that every single point along that line is defined. For each x you give me, if I'm right here, I say, okay, x is equal to 1. What's y equal to? And I can say, well, y is equal to 1. Right here, x is equal to 3. What's y equal to? I can say y is equal to 1. But right here at this point where x is equal to 0, we can't well, what we're going to what we can we know that f of x is not defined at that point. So our graph has to reflect that, and the way we do that is we put an open circle right there at that point to show that right there at that point, at the point x is equal to 0, our function is undefined. Now here's pretty much what a limit is going to be asking. If we said, okay, and this is the notation that we're always going to use. If we said, what is the limit? So that's LIM, and then right under it we have x and arrow 0. So what is the limit as x approaches 0 of x over x? So this is like saying, pretty much what this is saying when we write this down, the limit as x approaches 0 of x over x, what this is asking is, well, even though we know that f of x is not defined at this point, we know that this is, I'll write down u, that is undefined right at that point, x is equal to 0. But the question we're asking with this, and it's important to realize this, we don't care what x actually is at 0. We can, a lot of the time what we're going to see in these limits is that it makes sense to kind of almost think about it that way, to think about, well, what would happen if x was equal to 0? But the important thing to realize is that we don't care what the function actually equals at this point. We don't care what x actually equals at 0. What we care about when we write this down, the limit as x approaches 0 of x over x, we care about, well, what does this function approach? So as x gets really close to 0, so as we move this way on our x-axis from this direction, so x is becoming less and less negative in this direction, or we could say x is becoming less positive as we come in this direction. As we approach x is equal to 0, well, what does our function approach? And just from this graph, and probably by a little bit of your intuition, you can say that, well, we know what this approaches. This is going to approach 1. And there are algebraic ways to prove it, and this is where you could say the limit as x approaches x over x is going to be equal to, and we can algebraically simplify that to say that that is equal to the limit as x approaches 0 of, and we're just going to cancel those out, of 1. And then we've got no x's in this expression. So if we were going to say the limit as x approaches 0 of some constant, and what if we were, this is the equivalent of saying, okay, our function here, actually I'm not going to call it f of x because I don't want you to think that this is the same function. It's not. This is a simplified version of f of x, but if we said our function, let's call this g of x right here. If we said g of x was just equal to 1, for any x you give me, the output's always going to be 1. X could be 1,000,000, output would still be 1. X could be 0, output would always be 1. So the limit of that function g of x is equal to 1, as x approaches 0, well, that's always going to be 1. So anyway, that's a little bit of an introduction to limits. The important thing to realize is, first off, that this is the notation. Limit as x approaches 0 of x over x. That's pretty much what you're going to be seeing, the notation in your calculus class. And this might seem a little bit, I'll definitely clarify this point in the future, and you'll start to see a bit more what I mean. But the really important thing to get about a limit is that we don't care what this function actually equals. So we know that at 0, this function is undefined. All we care about is what does it approach. If we could definitively say, we know that this is undefined right here, but what should it be? What would the value be if it were defined? That's what we're asking with this notation. So anyway, thanks so much for watching, and I'll see you in a future video.